So for this lecture, let's calculate moment of inertia of some of the objects. Okay, now before we start calculating moment of inertia, first of all we have to define about which axis. So because axis is important. So here this guy is going around this axis when you apply a force perpendicular to this, and let's say the mass of this thing is 4 kilograms, and let's not say 4 kilograms, let's say the mass is m and the length is L. This is the parameter. We really do not need to know, but let's also say that the thickness is D. That's the thickness, but that's not really going to play any role. Now about this axis, so we have to calculate moment of inertia about this axis, and we already have said I is given as m r square d dm r square dm, where all the summation should be over all the area, if it's because it's here it's two-dimensional area, but if it's a three-dimensional case, like a three-dimensional object which is moving about this axis, then the moment of inertia will be I equals r square dm. Here dm is going to be, we already have discussed this in previous class when we were talking about calculation of center of mass, dA, and in this case dm is given as rho dV, where here is the volume element dV and this is R, right? And sigma is area, well, is mass over area, that is the mass density for some area, and rho is the mass density for the volume, mass over volume. So here we are actually talking about this, and you will actually always be talking about that, at least at this level of the course. Okay, so that gives us r square dm, we can write as sigma dA, and A is the area of the whole meter stick, so that is the mass density, and that gives us r square. Sigma is going to be m over A. Let's say A is the area of the stick, which is LD, right? A is because it's a rectangle, and also dA, right? So we are talking about this axis, so we have to choose a small dA, which is somewhere here, which has a thickness of dx and which is at a distance x from the axis, and write this area. So what is the area of this small element, which we are going to write as dA? For this case it becomes x square, because r is the distance from the axis and the mass element, and this is the mass element, and x square. What is well, m over A stays m over A. What is dA? Well, dA is dx times the thickness d, right? This is the area. Let's take m over A outside, and that leaves us with x square. Well, let's take d also outside, and that leaves x square dx. X is going from 0 to L, so 0 to L, and that this is d and m. Okay, don't get confused with this dm, they are different things. I'm sorry. You can write it md if it's confusing. M is the mass, d is the thickness, so it becomes md over A, you know, is LD, and this gives us, if you do a small calculation, this will give you L cube over 3, and that, if you solve, gives you ml square over 3. So this is the moment of inertia of a meter stick about an axis which passes through the end of the meter stick, right? So you're looking at a meter stick from the front and you hinge it in. It's like a door. It's like when the way the doors are hinged. So this is same as door, and the doors move around an axis at the end, and if you apply force and push the door, it goes in a circle or moves in angularly. So for this particular axis, this is the moment of inertia. And let's take one more case. And what we have here, we already have calculated center of mass for this kind of object, and we have, this is the axis, and for this axis we have to calculate moment of inertia of this triangle about this axis. Instead of a ruler stick, we have this triangle, and again we have to calculate r square, with r is the distance between the axis and the mass, dm. So similar to previous case, we take a small area element. This is the area element, which is a thickness dx. The reason why I have took it like this is because every point in this area element is at some distance x from the axis about which we want to calculate I. Okay, as we talked earlier, r square is nothing but x square, and dm is nothing but sigma dA. Sigma is the mass density, and this is nothing but x square. Let's say we should have specified this is L, this is L, and the mass is m. Okay, what is sigma? Sigma is going to be m over a times dA, but dA is a small area element, which is going to be dx times this length, and this length should actually be, if this length is x, this length will also be x. You can understand using geometry how. So if this is x, this is also x, so this is x. So what do we get here? We get m over a x cube dx, and if you simplify this, you get m over a, I think this should give L over L power 4 divided by 4. That's what you will get if you do integration. We already know a, where a is the area of the triangle, which is half into base into height, and that gives you L square over 2. So if you put L square over 2, you get m L square over 2. This is what you get for the triangle. Okay, this is all calculus and geometry, and this is what you have to calculate. To contrast with the discrete system, which we should have talked earlier instead of talking continuous system before, or but let's cover that also. Let's say you have these masses. Let's make it somewhere here, and you have defined your x-axis like this. Okay, and this mass is 1 kilogram, this mass is 2 kilogram, this mass is 3 kilogram, and this mass is 4 kilogram. Okay, and this guy is 3, 2. This guy is 2, 2, and let's say this guy is minus, well, this should be actually a negative sign because x is negative here, and this guy is, let's say, 4, 3, and this guy, let's say, is 2 comma minus 1. Okay, and we have to calculate moment of inertia about this axis that is going into the plane or out of the plane, doesn't matter. So we have to calculate moment of inertia of this system, which is joining like this. So you see it's sort of a weird thing which is going to rotate about this axis like that. So what is moment of inertia? Well, I for discrete system is same as that, but in a discrete way, is mi ri squared. So what is mi r squared, or sum over all I? What is mi r squared for all these masses? Well, for the first mass is 1 is the mass. What is r? R is the distance between the axis and the mass, which is 3 squared plus 2 squared. Square root of that gives you square root of 13. The r is square root of 13 here. How about this? This is square root of 8. So plus 2 times square root of 8 plus, how about this one? This gives you 3 times 5, actually square root of 25. And how about this? This gives you 4 times square root of 5. So this is the moment of inertia. You can use your calculator to find these values about this axis. So this is how we calculate moment of inertia.